Hello to everyone. In today's video, we are going to be looking at partial fractions. Now, this question is taken from GCE Mathematics June 2021, question 1 sub 1. The question says, express 5x divided by x plus 3 into x minus 2 into partial fractions. 3 marks. First of all, we verify if it's a proper or an improper fraction. The highest degree in the numerator is 1. Because this is a linear function, and the highest degree in the denominator is actually 2 because you expand these fractions. If we expand this function, we're going to have x squared minus 2x plus 3x minus 6. So the highest power there is 2. Therefore, we have in the numerator have 1 and in the denominator have 2. Since 1 is less than 2, therefore this is a proper fraction. So we are very free to go ahead and simply express it. Now to express it, we already saw the conditions. So since this is a linear function, we're going to use a constant a divided by x plus 3. Now since here also is a linear function, we're going to use a constant b divided by x minus 2. Now we have to take note that the denominator here is supposed to be the same as the denominator in the original fraction. So we're simply going to copy that x minus 2. Make sure that this and this are the same. Now, if we take the denominator and we bring it, we divide by x plus 3, we are going to have x minus 2. So here we have a into x minus 2. So if we do the same thing here, we're going to have b into x plus 3. Now we're going to compare this because remember, this was 5x divided by x plus 3 in x minus 2. Comparing our numerator and the denominator, since the denominator here is the same as the denominator here, the numerator should also be the same, since we are apparently dealing with the same fractions. Remember, we want to express this in another form or in a much simpler form. So it means that our 5x will simply be equal to a into x minus 2 plus b into x plus 3. We're going to call this our equation star. Now to look for the value of a and b, we have to use either substitution or we compare coefficients. Now method 2, using comparing coefficients. So in this case, what we need to do is simply we expand the right hand side and we compare the coefficients. So expanding our right hand side, we're going to have in the left hand side we have 5x to be equal to, expanding this, we're going to have a times x, we're going to have ax. A times minus 2, we're going to have minus 2a, plus doing the same thing for b, we're going to have bx plus 3b. Here we have 5x. We can look at this as 5x plus 0, since 0 is a constant. Here we simply bring our like terms together. So I have 5x plus bx and minus 2a plus 3b. We see that these are constant term. These are the terms in terms of x. So we have 5x plus 0 to be x is common. So we have a plus b into x minus or plus negative 2a plus 3b. Now comparing our coefficients, what are we going to do? We notice that the coefficient of x on the left hand side is 5. Therefore, the equation of x on the right hand side should also be 5. It means we are going to have a plus b to be equal to 5. This is our equation 1. Now we'll do something similar to the other constant. Since our constant on the left hand side is 0, therefore the constant on the right hand side should also be 0. It means that minus 2a plus 3b should be equal to 0. This is our equation 2. This is simultaneous equations, or these are simultaneous. This is a simultaneous equation, and we know the various methods in which we can use in solving a simultaneous equation. We can use substitution. We either make one of the variables subject in equation 1 and substitute in equation 2, or we vice versa, or we simply go by elimination. I would prefer elimination in this case. So what's the first thing we need to do? For elimination, we're going to take our equation 1 times 2. It means that our equation 2, our equation 1, by substituting this here, means we're going to have 2a plus 2b to be 10. So this is our equation 1 star. We're going to use equation 1 star with equation 2. So using equation 1 star and equation 2, we're simply going to take equation 1 star plus equation 2, equation 1 star plus equation 2. We notice that 2a plus minus 2a here is going to cancel, so it's going to give us 0. So 3b plus 2b here, this will give us 0 plus 10. Therefore, our 5b will be equal to 10, which implies b will be 2. So we have our value of b to be 2. We can simply substitute this value of b equal to 2 in our equation 1. So b equal to 2 in equation 1, we have our equation 1 says a plus b, right? A plus b equal to 5. So a will simply be 5 minus 2, which will be 3. Therefore, a will be 3. Good. Having b to be, a is 3, and b is 2. If we substitute in our original fraction, we're going to have 3 divided by x plus 3 plus 2 divided by x minus 2. So giving us the original value that we had, or the original partial fraction that we had before. That is it for this video. If you found the video helpful, consider subscribing and turning the bell notification on, so that whenever I upload new videos, probably in all the subjects in chemistry, physics, mathematics, further maths, mechanics, and even statistics, you'll be notified. So make sure to subscribe and turn on the bell notification. Also, consider liking the video so that it can help in the YouTube algorithm, so that the video can reach to more people, and it's also a form of supporting what I'm doing. And consider sharing it with your classmates so that they can also benefit from the knowledge in this video. So download the complete GCE equation in the description box. There's a free downloadable link to the equation in the description box and also in the comment section. So see you in the next video.